Hi friends, welcome to my channel Math Mantra. Today I have come up with yet another topic in statistics, correlation. In this video I will be discussing with you what is correlation, its definition, different types of correlation and its graphical interpretation. If you are new to my channel, please like, share and subscribe my channel for the forthcoming videos. So let's get started with the topic. Let's begin with the definition of correlation. Actually, the word correlation comes from two words, co and relation. Co means together and relation means connection. So correlation means the relation connecting two variables. Actually, correlation measures the strength of the relationship between two variables. The variables involved are independent variables as well as dependent variables. Now let me explain you what is independent variable. The factor causes the dependent variable to change is called independent variable. I'll give you an example to make this concept more clear. Suppose we consider profit and investment. If you have more investment, definitely the profit will be more. So we can say investment is independent variable here and profit is dependent on investment. So profit is a dependent variable. Similarly, salary and years of experience. Salary depends on years of experience, where years of experience will be independent variable. Men and work. When we have more men, definitely the work done will be more. So, work depends on how many men are involved in the work. So, men will be independent variable and work will be dependent variable. So, that's all about independent variable and dependent variable. So, when we find the correlation between two variables, one variable should be independent and the other variable should be dependent. Now let us see different types of correlation. First, we'll start with positive correlation. As the independent variable increases, the dependent variable also increases. Such a correlation is called positive correlation. Normally, when we plot the graph of correlation, along the x-axis, we take independent variable and along y-axis, we take dependent variable. Now let us see how we are measuring correlation. We use the coefficient of correlation to measure correlation. It is denoted by small r and we call it as coefficient of correlation. Let's see the different possibilities. First of all, positive correlation always lies between 0 and 1. When r is equal to 0, it means that there is no relationship between the variables. That means the variables involved are not related to each other. When r is equal to 1, we can see there is a perfect positive correlation between the two variables. Now see the ranges of values of r and its interpretation. When r lies between 0 and 0.5, it indicates that the relation connecting the two variables is a weak relation, or we can call it as it is a weak correlation between the two variables. When r lies between 0.5 and 0.7, there is a moderate positive correlation between the variables. Last case is when r is between 0.7 and 1, the relationship between the two variables is very strong and we call it as a strong positive relation. Next is negative correlation. As we discussed in the case of positive correlation, here what is happening is as the independent variable increases, the dependent variable will decrease. So that means they are moving in opposite direction. So here when r is equal to -1, there is a perfect negative correlation. When R lies between -1 and -0.7, the relation is strong negative correlation. Also, when R lies between -0.7 to -0.5, there is a moderate negative correlation. And lastly, we can say when the R value is between -0.5 and 0, the relation is weak negative correlation. So this is all about negative correlation. Now moving on to comparison of correlation. So I have taken a number line and marked -1 and +1, between which the value of R lies. Now as you can see from this, between -0.5 and 0.5, the relation is weak. That means the correlation between the variable will be weak correlation when R value lies in this first interval. Then as the values of R moves towards the left and the right, as indicated by the arrows, the relationship between more stronger. And when it is close to -1 and +1, it becomes strong positive as well as negative correlation. So hope the values of R and the corresponding strength of correlation is clear to all. Now let us see the graphical representation for the correlation. First let's see positive correlation. Now when we take positive correlation, as I have already mentioned in the earlier slide, along x-axis we have to take the independent variable, along y-axis we have to take dependent variable. So here I have taken years of experience, which is independent variable along x-axis, and salary along y-axis, which is dependent variable. So you can see the graphical representation. You're getting a straight line and all the values are clustering near to the straight line, and the slope of the straight line will be positive. This gives you the interpretation for positive correlation. Now we pass on to negative correlation. In the similar manner, we consider negative correlation. Here I have taken an example, price and demand. As you know, as price increases, demand will be decreasing. Why? Because everyone will not be able to afford the commodity when the price is higher. So definitely demand will be decreasing. So along x-axis, as the values are increasing, along y-axis the values are decreasing. And the figure that represents the negative correlation, it's a straight line, as you can see on the graph. And the points are clustering near the straight line. Hope this is also clear to you. Now we move on to the next case, no correlation. Here all the points or all the variables x-axis and y-axis, you can see they are scattered. There is no relationship between the variables. They don't follow any specific rules here. So such a relation is called no correlation. The variables have no relationship among themselves. You can take an example, time and grades. Time spent for studying and grades. We can not assure how much time you are spending will be reflected in our grades. It is up to the value time that you spend for learning, your grades will be reflected. So there is no specific relationship between time and the grades allotted for the academics. So hope this is clear to you. So that's all for this video. I hope today's class is beneficial for you. If you have any doubts regarding any of the concepts discussed today, please message me in the comment box. You can also suggest me the topics which you want to see in my videos. So thank you for watching my video. Keep watching. Until the next video, take care. Thank you.